So now we're going to start talking about the periodic table and how it's organized. So if we look at our first slide, or first part of your notes, organizing the elements, there we are. So there's not much in here that you need to remember other than the fact that a Russian scientist, Mendeleev, Dimitri Mendeleev, was basically the founder of the modern periodic table. So back in 1865, there were only 63 known elements, and this scientist decided to list the elements in order according to their atomic mass. And here's sort of what it looked like, this picture here. The table was organized in such a way that the elements with similar properties appeared in the same column. So he started out by organizing them from start to finish according to mass, and he had this big, huge, long line of elements, and then he decided, you know what, I'm going to separate them into different rows, and what I'm going to do that is put the elements that have the same properties together. So he realized that, say, lithium, sodium, and potassium all reacted sort of the same, so he put them in the same column and started to organize the periodic table that way. And this was actually really cool because what he realized is that there were gaps. So these little pink areas here, these were elements that at that time had not even been discovered yet. So check this out. So Mendeleev, like I said, the table contained some blank spaces where no known elements were appeared to fit. So Mendeleev was smart, and he was able to predict the existence and properties of these undiscovered elements. So for example, he predicted that there would be an element with the properties of germanium between, the properties of germanium between, there's a missing word there, so there should be gallium in there. Okay, so silicon. My bad. Silicon. So here's silicon right here in blue, and here is tin. So they knew about these two elements, but they hadn't discovered yet germanium. So this was one way that they actually discovered it. Now I've got two videos at the bottom here. We're actually going to watch those in class to save you guys time when you're taking your notes. So the modern periodic table, like I said before, he organized all these elements according to their mass, but there were some errors this way. So if you look at tellurium and iodine, they're number 52 and 53 on the periodic table as we know it today. So here they are down here. And if you look, if I arranged these in order of atomic mass, iodine should actually come before tellurium because it's got a lower mass than tellurium does. So people realized this and discovered that some of these elements weren't being grouped according to their properties, so they rearranged it and redid the periodic table according to atomic number, which is the same as the number of protons. That's what we learned in the last video. So, periodic law, this is important. The chemical and physical properties of elements repeat themselves in a regular periodic pattern when they are arranged according to their atomic number. So this makes it, the periodic table, really useful because we can look at it and know right away how some elements are going to react based on where they are. So I've got another video that I'm going to show in class, and we'll look at that after. So we've got lots of different categories on the periodic table, how it's organized. So we've already talked about the groups. Those are the columns in the periodic table. And elements in the same group that are in the same column have the same chemical properties. Elements in the same group also have the same number of valence electrons. So if you look at these two statements here, it kind of shows you that the valence electrons are actually what's going to determine how an element reacts or its chemical properties. So valence electrons are really important, and that's why we spend a lot of time on them in this course. Periods are the rows of the periodic table. Elements in the same period have different chemical properties. Okay, they all have different numbers of valence electrons, and so they do all react differently. However, the elements in the same period have the same number of energy levels. So everything in period 3 will have 3 energy levels. So if we were to draw our Bohr-Rutherford diagram, say of sodium, Na, it would have 11 protons in the middle, and it would have 12 neutrons in its nucleus, and then it would have, if we drew the whole thing, which I don't really have room for, it would actually have 3 different rings around it, and now we call those energy levels. So for example, can you find the element in group 5, period 4? This is important. It's also always on your final exam as a multiple choice question, so make sure you know how to answer this. So for group 5, period 4, a group means the column, so the 5th group and the 4th period. Can you find it? Try right now. I'm looking on the periodic table because I don't even know what the answer is. We're looking at V, vanadium. Okay. Also, your physical state of each element is indicated on your periodic table in your textbook. So if it's written in red, it means it's a gas. If it's written in blue, it's a liquid. And if it's written in black, that means that element is a solid at room temperature. Okay, a couple of other groups on the periodic table that you have seen before are the metals, nonmetals, and metalloids. So metals, most of them are solids. They're metallic looking, so they're sort of that gray, shiny, lustrous look. They conduct heat and electricity very well. And they're malleable or ductile. Malleable means we can bend them, and ductile means that they can be pulled into wires. Nonmetals are solids, liquids, or gases at room temperature. There's no set rule for them. They don't conduct heat or electricity very well. They're very brittle, so if you try to break them, they just snap apart. And they're really brightly colored. Metalloids are those ones that are kind of like metals and kind of like nonmetals at the same time. They're usually poor conductors of electricity, but they can still be shiny. They're not super great at being bent, so they are brittle, and basically they exhibit metallic and non-metal properties. So, you need to know all of these groups on the periodic table and how it's organized. Some groups and the two series of elements, which are the horizontal rows at the bottom, have very commonly used names. And the position of hydrogen on the periodic table is problematic. It behaves sometimes like an alkali metal, sometimes like a halogen, and sometimes in its own unique way. So it's sort of in a class all by itself. But what you should have done in class or at some point is actually color in a periodic table and know the different elements that are present. So we have the alkali metals. They are in group 1 and they don't include hydrogen. The alkaline earth metals are group 2. The transition metals are all of these metals in the middle here that we didn't use too much of in grade 10, and we're going to start looking at them in a lot more detail this year. Your halogens are way over here in group 17, and your noble gases are in group 18. Your lanthanides and your actinides are down here. So the lanthanides are this top row, and the actinides are the bottom row. Okay, you don't really need to know those too much. We usually just call them the rare earth metals. And the only other groups that you can see on here are kind of not really classified. So we've got green and we've got the purple. Those all together basically consists of the rest of the non-metals. So they don't really have, oops, not no metals, non-metals. Try that again. So these here are non-metals. Okay, so they don't have a specific name. You just need to know that they all act like non-metals or metalloids because they are on that staircase, right? So they don't really have a specific name. So we've got the green non-metals, those purple ones. A lot of them are metals. Some of them are metalloids. But you do need to know where to find the metals, the non-metals, and the metalloids on your periodic table. So what we're going to do in class, we're going to make our own periodic table using a couple of pages out of our textbook, so don't worry about that right now. The key terms from this video are periodic law, which are the trends or the patterns in the periodic table, and then a period, which is a row on the periodic table, and a group, which is a column on the periodic table. You do need to know those from now on. If you have any questions, be sure to bring those up in class.